All right, good. So let's start off with the lesson 9. Still about equations of a plane. We have case 3. Case 3 is going to begin with. Case 3, they are saying, now I said cases, these are ways in which an examiner can base. They can say to bring this come 2025. So case 3, given a point in a plane with the two parallel vectors. They are going to give you a point in a plane and the two parallel vectors. All right, so point in plane is OA. You all know that. So shall say solution. Now with the two parallel vectors, okay, let's say find the equation of the plane with two parallel vectors. The first parallel vector is this and the second parallel vector is that. So we shall now say that u1 is equal to first parallel vector is 1, 1, 1. Oh, like we are. Then the second parallel vector is 2, 1, 3. Like we are. Those are two parallel vectors. Good. Huh? And the point, so a point OA. A point on the line, you always be calling it OA regardless of what I put there. 3, 2, 1. That's our point. Then, we shall now say from. Remember this always. From nor equals to nowhere. Like that. You must always be remembering that. Now, what you do here is, we need to get the normal vector, but normal vector we get it from what? I said in lesson 8. In lesson 8, I said that when you cross two parallel vectors, you get a normal vector. So therefore, we shall now say that to get a normal vector, we shall cross the two parallel vectors. Mu1 cross mu2 will give us a normal vector. And allow me to do it from somewhere here. So that will be that a normal vector is equal to, oh, can I cross them just right out here? No way, space can be enough. So this will give us, I want to cross them. This will give us cross another value here. So mu1 is 1, 1, 1. Mu2 is 2, 1, 3. And I want to cross them. So in the crossing, we said we go about the covering, but for me, I'll go direct. We all know how to cross. If you don't know how to cross, go in lesson 2 in the playlist. Then you learn more about how we go about the crossing. For me, I'll be going direct. So cover up this. 3 times 1 is 3 minus 1. So you shall have a 2. Now here in the second part, we have a negative by default. Negative is there, I must. Okay, this. Okay, 3 times 1 is 3 minus 2, that is 1. So negative 1. Cover up down. We have 1 times 1 is 1. Minus 2 will be negative 1. Please, you must be knowing how to cross vectors. You go and watch lesson 2 in the playlist. Then you know how we go about the crossing. Okay, good. So here, I'll now say nor is equal to nowhere. So this will be equal to, I'll now bring, say, a 2, negative 1, dot, the OR is xy, z is equal to a 2, negative 1, sorry, dot OA. OA is a point on the plane which is a 3, 2, and a 1. So multiply this will be 2 and x. Okay, minus y minus z is equal to 2 times 3 is a 6 plus, okay, minus negative 2. Negative 1 times 2, then minus also 1. So therefore, our equation of a plane will be 2x minus y minus z will be equal to just 3. And that is your equation of a plane. Okay, we are on the second part. Given two lines in a plane, please, this formula here, nor nowhere, will help us finish up the whole numbers of plane. It's a simplified version. Better I need to go in the playlist, watch and watch and watch. Don't, of course, forget to subscribe. Okay, find the equation of a plane with lines. Now we have two lines. They've only given us lines. And now they want equation. They want an equation of plane. So what are we going to do? What are we going to do in simple terms? So now we shall say that now in our solution, now those lines there, you must be able to get the parallel vectors. I said the parallel vectors are got from, the parallel vectors are got from the denominators, or the coefficient of lambda gives us the parallel vectors mu1 and mu2. Give us the parallel vectors mu1 and mu2. All right, good. So let us proceed. Let us proceed. So now let's say solution. So my line 1, the first line R is equal to, so 1, 2, 1, like that, plus lambda, this will be 2, negative 1, 1. Then the other line, R is equal to, I want to bring it in this format, plus. Now, if here you have lambda, here don't again put lambda, you can call it alpha. Let them not have the same coefficients here. So, the point on the line, now this one's here. Here we get denominators, so 3, 2, 1. So up x equals to 0, x plus 1 is equal to 0, shall get negative 1. We shall get a negative 2, then we shall get a 1, like that. So now what we call the coefficients, these ones here, they are those which give us this one, the coefficients of lambda. Now this is your u1, and now this one here is your u2. Please better know that your u1 is there and your u2 is there. So therefore we shall say that to find the equation of a plane, we need a normal vector, which is u1 cross u2. But we already have them. So normal vector will be equal to, let's cross a 2, negative 1, 1. You cross it with, all right, you cross it with negative, sorry, a 3, 2, a 3, 2, 1. So our normal vector finally will be what? Shall get our answer. I will be going to direct the answer because lesson 2 has the whole explanation of how we do it. So cover up this. This will be 1 times negative 1. 1 times negative 1 is negative 1 minus 1 times 2 is 2. Then we shall get a negative 3 up here. Negative 3, cover up down. But there is a negative by default. There is a negative by default there. So 1 times 2 is 2 minus 1 times 3 is 3. This minus that will give you a negative 1. But since there is a negative by default, it will now become a positive. Please go in the lesson 2 and learn how we do the crossing. Lastly here, I'll close here. So 2 times 2 is 4. 4 minus negative 1 times 3 is that. So you shall end up getting a 7. And now that is our normal vector. All right, good. So a point on a plane. Now, since these lines are in a plane, these lines are in a plane. Like say, for example, if this is your plane, and maybe this is the line, and this is also a line. It means that this is the line and that is a line on a plane. It means that the point on the line is also a point on the plane. So therefore, point on the plane, you can call it the point on the plane OA. You can call it anything you want. For me, I will choose this. Another person may choose this, no problem. Me, I'm choosing this. It is 1, 2, 1. You choose any, whether this or that. The point on the line is a point on the plane. Why? Even the lines are on a plane. So now, therefore, I will bring in the NOR equals to Noah. NOR equals to Noah. Now the normal vector is negative 3, 1, 7, dot, okay, x, y, z is equal to the Noah, n is negative 3, 1, 7. Oh, Noah, this is a. Noah, that is a dot. The A I've taken 1, 2, 1. Please, the point on the plane is the same as the point on the line as per what we are having. So you dot. So this times this will give us a negative 3x plus y, 1 times y, plus 7z, okay, equals to negative 3 plus 2 plus 7. So our final answer will be negative 3x plus y, oh, 7z, this is 7z, plus 7z is equal to, simplify here, negative 3 plus that, negative 1, then we shall get a 6 there. Then you can leave it as that, or you can divide it through by negative. When you divide it through by negative, you get 3x minus y minus 7z is equal to 6. As simple as that. And now that is our inequation of plane in simple terms. Let us proceed. All right, good. So we are now looking at the last case, case 5, about the planes. Let's look at the last case, and of course that will be the end of the equations of a plane. Another work would be, now here, when given a line and a point on a plane, given a line and a point on a plane, what do we do? Given a line and a point on a plane, so shall say solution. given a line and a point and a plane, given a line and a point and a plane. So what I'm going to do here is, shall now say that from R, vector is equal to 301 plus lambda. What you aim for is to get the normal vector. How do you get normal vector? You cross two parallel vectors. As simple as that. So 1, negative 1, 1, like that. Okay. I'll extend this one, the solution this side. Now, having done that, I am aware that this one is our mu1, the first parallel vector. This one here is our mu1. Then the point on the plane, point on a plane is equal to, point on the plane is equal to 1, 1, negative 2. That's the point on the plane. Now, I have mu1, I have u1, but I want a parallel vector whereby I have to cross u1 times u2. Then what am I going to do? What are we going to do? Now, to get u2, this is your u1. To get u2, you say u2 is equal to point on a plane. You subtract point on a plane minus point on a line. Okay? To get u2, shall subtract point on a plane minus point on a line. So therefore, what are we going to have in the end? You shall say point on a plane minus, remember u is a parallel vector, and I said that to get parallel vectors, we just strictly subtract. And now there, when you subtract, what do you really get? Shall start with, okay. Let's start with the point on the line. Already start with the point on the line minus point on the plane. So point on the line is 3, 0. The point on the line is this 3, 0, 1 minus the point on the plane. The point on the plane is 1, 1, negative 2. So this will give us u2. What will be your u2? Here u2 is, okay, 2, negative 1, 1 minus 2 is a 3. That's my u2. Now to get a normal vector, you cross u2 minus u1 cross u2. u1 is here, so u1 cross u2. That's what we're going to do. So let's go about the crossing. Okay, maybe you can even put here and say, okay, and say u1 is 1, negative 1, 1. u2 is 2, negative 1, 3. Let me see if this can be seen clearly. We may end up not bringing it out. All right, good. So a piece of paper. We want to cross. So what will be our normal vector? Finally, after crossing, what will be our normal vector after crossing? Now I'll put here, cover up this. I'll be putting a final answer here. Please go in lesson 2 and watch. You learn how to cross. So 3 times that is negative 3. Negative 3 plus 1 is negative 2. So you have negative 2. Then there's a negative by default in the second part. 3 times 1 is 3 minus 2 is 1. So negative 1. Then here, cover up to be now negative 1 plus 2 is a positive 1. So we have a normal vector as that. Now you also say from Noah. From nor is equal to Noah. That's what you're using. Be a bit interesting. Our normal is 2, negative 1, 1. Our general is x, y, but z is equal to, our normal is a negative 2, negative 1, 1. And our point OA, the point on a line, point in a plane. What is our point in a plane? The point in a plane was this. So 1, 1, negative 2. Don't get confused. Here we use the point, OA is the point on a plane. So now you can dot, or so 2x dotting. 2x minus y plus z is as good as a negative 2 minus 1 minus 2. Oh, bit interesting. So negative 2 and x minus y plus z is equal to, harmonize here, shall have a negative 5. Divided through by negative, you get a 2x minus y, rather plus y, minus z is equal to 5. And that is your mighty equation of a plane. Don't forget to subscribe.